Hello everyone. In order to understand the 10 Python rules, I'll be going over examples using Python Tutor tool. Let me switch to the Chrome window. I'm already on the course website. I'll be clicking on Tools and Python Tutor. Let me click on Live Programming Mode. In this video, I'll be covering the rules for local variables. There are 4 rules for local variables in Python. I'll be going over an example for each rule, following which I'll state the corresponding rule. Let's get started with example number 1. I'm going to define a function called set underscore x. So I'll have to type in def space set underscore x, open parenthesis, close parenthesis, followed by a colon. Within the function definition, I'm going to initialize a variable called x with a value of 100 by saying x equal to 100. Outside the function definition, I'm going to call the print function to display x. How can I say that the print function call is outside the definition for set underscore x? Observe that the print function call in line number 10 is at the same indentation level as the def keyword in line number 7. So the print function call in line number 10 is outside the function definition for set underscore x. Notice that I am getting an error in line 10. How can I view the details of the error? I can click on the black arrow on the bottom right to resize this window. The error here states that name error, name x is not defined. Rule number 1 is very simple. It states that functions don't execute unless they are called. You're already aware about rule number 1. In order to use a function, you need to explicitly call the function. Let me try to fix this problem by calling the set underscore x function. Observe that we are still getting the same name error. Let's step through this program from the beginning. I can do that by clicking on the first button on the bottom. Whenever we define a function, the program execution is going to skip over the lines of code within the function body. So now when I click on next, the program execution will move from line number 7 directly to line number 10. Notice that we got a global frame in the visualization. Within the global frame, you have the function name, which is set underscore x. For now, don't worry about that. Eventually, we'll learn what that means. When I click on next now, the program execution will switch from line 10 to line 7. That's because I'm calling the set underscore x function. This time, notice that you got a new frame which is tagged as set underscore x. The currently active frame in Python Tutor is marked using the light blue color. Since we are currently executing the set underscore x function call, that is the currently active frame. Now when I click on next, the program execution will move to line number 8. We are creating a local variable called x and initializing a value of 100 to x. So within the set underscore x function call frame, a variable x will be created, and within that box you're going to get the value of 100. Recall that the implicit return value from a function is the none value. Since we don't have an explicit return statement in the set underscore x function, the function call is going to return none. Now when I click on next, the entire frame for set underscore x function call will vanish along with the local variable x. Since we are not doing anything with the return value in line number 10, the execution is directly going to go to line number 11. Let's see whether the set underscore x frame vanishes when I click on next. Observe that everything got deleted. Now when I execute line number 11, it's going to give me a name error. That's because there is no variable called x within the global frame. Rule number 2 states that variables created in a function die after the function returns. Whenever a function execution is completed, the associated frame for that particular function call along with all the local variables will get deleted. Let's move on to the next example. I want to define a count function. So I'm going to say def space count open parenthesis close parenthesis followed by a colon. I'm going to initialize a variable called x with a value of 1. I want to increment the variable x by 1. Recall that the term increment refers to increasing the value of a variable by a specific value. I can increment the value of x by 1 by saying x equal to x plus 1, or I can use the syntactic sugar and say x plus equal to 1. X plus equal to 1 is a shortcut for saying x equal to x plus 1. Let me call the print function to display x. I'm going to call the count function 3 times, but I'm going to comment out the function call for now. I want you to think about what the output of the program will be when I uncomment lines 12, 13 and 14. Please pause the lecture video here and write a comment in the comment section stating the output of this particular program. If you were thinking the output will be 222, then you had the correct answer. How come the output is not 234? That's because of rule number 3. Rule number 3 states that variables start fresh every time a function is called. Let's try to understand rule 3 by stepping through this example. I'm going to click on first. When I click on next, the program execution will go from line 7 to line 12 directly. Within the global frame, you'll have the entry for the count function. The first invocation of the count function will create a new frame called count. Now, when I click on next, it's going to run line number 8 and we'll have a local variable x created. When we increment the value of x in line 9, the value in the box beside the x variable will get updated to 2. We are calling the print function to display x, so that will display 2. The implicit return value of none will get returned, and your program execution is directly going to move on to line 13. Now when I click on next, the function frame for count function call will get deleted along with the local variable. So next time when I call the count function, that's going to create a brand new function frame for me. So once again, x will be initialized to 1, it will get incremented to 2, and we'll get output to the display box as 2. This time the count function call frame will get deleted again, and final call will give you the same result as the output of 2 within the output box. Let's move on to rule number 4. I'm going to define a display underscore x function for the last example here. Within the display underscore x function, I'm going to call the print function to display x. Let's say that I want to initialize x outside the function here, and I want to call the display underscore x function. Notice that you're getting an error which states name error, name display underscore x is not defined. I thought I defined the display underscore x function. What is wrong here? You cannot call a function whose definition comes below the function call line. Python does not accept that. A lot of programmers try to use a workaround to get around this problem. Let's say that for some reason a particular programmer wants to specifically make this function call before the function definition. The workaround is for you to define a main function and move all the lines of code outside any function within the main function. So now you can call the main function. Notice that you're getting name error now, which states name x is not defined. Let's step through this problem from the beginning to understand the name error. we have main function. So we are going to skip over the lines of code within the function body. Then we have the display underscore x function. So the line of execution will directly move to line 14. Now we are calling the main function. Within the main function, we create a local variable called x and initialize the variable to a value of 100. Then we are calling the display underscore x function. Another frame will get created for the display underscore x function call. Now when we try to call the print function to display x, you're going to get name error. That's because there is no variable x within the display underscore x frame. You cannot see the variables that are present within the function which call you unless you explicitly pass those as arguments to parameters to the display underscore x function here. So that's going to be rule number 4. Rule number 4 states that you can't see the variables of other functions, even those that call you. As you can see, even though the main function here called the display underscore x function here, since we did not pass x as an argument to display underscore x function, display underscore x function cannot see the value of x here. So I'm going to finish typing this rule where I'm saying even those that call you. That will be it for this video. In the next video, we'll talk about rules for global variables.